Hi everyone, welcome back to the channel. In today's video, we are going to understand a very important topic in system Verilog verification. Types of assertions in system Verilog. Types of assertions. Okay. System Verilog has two main types of assertions. Immediate assertion, concurrent assertions. Within concurrent assertions, we have assert property, assume property, cover property. Now let's go deep into each one. Immediate assertions. Immediate assertions are simple checks that test a condition at the exact simulation time. They behave like if-else statement to catch instant error in logic. They cannot check sequential behavior across time like concurrent assertions. They are used to model combinational circuits. They are used inside procedural blocks, that is always block, initial block, task, and function. Syntax is assert expression, then there will be one else statement, and then there is the action. And now let us know when do they execute. In the active region of simulation, meaning exactly at that simulation time. They say they check only current values, no temporal behavior, no timing. Now let's see an example of this is a Rensick example. What we've written here, always at the rate of Paget's clock begin. Then we have given assert that condition count is equal to 15. Else the action is $fatal counter overflow then end. This means on every clock edge count must be 15. If count becomes 16, we get failure instantly. Now let's see another example. Divide by 0 sec. Here you can see assert condition is given. This expression not equal den not equal to 0. Else error divide by 0. Okay, if den equal to 0, that means assertion prints error. Now let's see one more example using inside task and functions. Inside this function, we have given an assert with expression I less than 8. If else, it will give this action will be $factor index out of range and function. It checks validity of function inputs. Now let's see when to use immediate assertions. We use them for simple debug checks like array index bounds, range checking, valid values, illegal conditions, basic one-step checks. It is not used for timing or handshake checks. That's for concurrent assertion. Now let's see what is concurrent assertion. Concurrent assertions are the most powerful part of system Verilog assertion. They observe signals over time. They check temporal behavior such as handshakes, protocols, delays, multi-cycle sequences, FSM, transition. These are written using property, sequence, assert property, assume property, cover property, which we will be seeing later in this lecture. They run parallel to simulation, not inside the block. Now let's see the example here. How we have to write concurrent assertions will have a sequence. This is the sequence. This is the property, and we have to add a clock signal. Okay. Then we have to assert that property. Okay, here we have written property P1. We have given the clock signal at the rate of Paget's clock. Then this is, if request is high, this is called a non-overlapping operator. Okay, this we'll be discussing later. If request is high, then grant will be high in the next clock cycle. Then AND property. Then we'll assert this property P1. Now we'll come to assert property. This is the main type of concurrent assertion. Checks that a property must always hold true. Example, handshake check. Okay, we have written one property, assert property, that we have given the clock signal at the rate of Pogge's clock, request is going. That means if request is high at the cycle end, this is a non-overlap. Since we have used a non-overlapping operator, grant will be high in the next cycle. That means in the n plus 1 cycle, grant will be high. This type of example is used for protocol timing. Okay, now I will show you the waveform explanation. Okay, first we have taken a 10 cycle timeline. This is the clock signal, this is the request signal, and this is a grant signal. Okay, what we have learned in the before example, that if request is high for the first clock cycle, that in the next cycle grant should be high. Here we can see, okay, in the first clock cycle request is 0. So in the next clock cycle grant is also 0. Now if we see the second clock cycle, for the second clock cycle request is high. So for the second clock cycle grant will also be high. Third cycle you will see it is 0. So in the fourth cycle grant is 0. Okay. And now you see at cycle 4, okay, request is high. That means grant will be high in cycle 5. Okay, since it is in the next cycle, grant should be high. If request is high, then again I am telling, if what is given in the assertion as earlier, if request is high in the first cycle, then in the next cycle grant should be high. So this is what it is happening here. At the cycle 7, when here you can say request is high. So grant is high in the 8th clock cycle. Okay, is it clear? If any of this fail, assertion will show error. Now let's see an example. Okay, assert property at the rate of Pogge's clock reset. Then we have used a overlapping operator. Okay, state is equal to idle. This means as soon as reset is high, state must be idle in the same cycle. When we will use non-overlapping operator, then it will the output it will show in the next cycle. But in case of overlapping operator, it occurs in the same cycle. Next, we will see an example of multi-cycle sequence. See, assert property we have given that A, that we have used a delay operator. See, what it means is if A will be high, then in the next cycle B will be high. Okay, and after again 2 more cycles C will be high. So if we'll consider this thing in cycle n, if A is high, then in cycle n plus 1 B will be high. And since we are considering the n position with respect to A, therefore C will be high when the cycle is n plus 3. This is not possible with immediate assertions. It is possible only with concurrent assertions. Okay, next we will move to assume property. In assume property, it is used mainly in formal verification, not simulation. Okay, you use assume to constrain environment signals. Now let's see the example. Assume property at the rate of Pogge's clock. Request, if request is high, error must not be high. Okay, in the same cycle, since we are using an overlapping operator. We will be discussing about overlapping, non-overlapping, all those things in the next video. The formal tool assumes the rule and tries to prove design correctness. Okay, this it is used in formal verification, input constraints, preconditions. Now let's move to cover property. It is used for coverage. It checks whether its scenario ever occurred. Example is cover property at the rate of Pogge's clock request. Then we have used a delay operator of 1, then grant. This records that request followed by grant happened at least once. It is useful for coverage driver verification. Let's take another example of cover property. This is an FSM transition coverage. We have used cover property and we have given clock. Then state is idle. Then in the next cycle, state is busy. This proves the design can transition from idle to busy. Okay. Now we'll summarize everything in a table. Okay. Okay, this one is mistakenly written. These are the conditions. Okay, these are the keywords. For immediate, we are using immediate keyword. Assert property, we are using assert property. Assume property, we are using assume property. Cover property, cover. What is the purpose? Okay, immediate is used for one step check, and assert property is used for protocol check. This is used for assume properties for formal verification, constraint inputs, cover property is used for coverage. Okay, and how it's written, where it is used, immediate property is used inside always blocks, then assert property is used for handshakes and timing. Assume property is used for formal verification and cover property is used for test scenario if the scenario occurred. Now let's see some good coding practices for system Verilog assertion. Okay. Uh, okay. Before seeing the good practices, let's see something else. When to use this assertion? Okay. Use immediate assertion when checking simple current cycle values. Debug inside procedural blocks, range, index, illegal condition. Okay. We use concurrent assertion when checking multiple cycle protocols, monitoring sequence like from request to grant, then FSM transitions, which we've discussed here before, bus protocols like AXI, HU, PCIe. That assume is used when running formal verification constraining environment behavior. Then we use cover property. That one is used when collecting coverage, monitor scenarios. In the monitor, we take the coverage, how much percentage of the things we have covered inside it. Then ensuring design resets a state. Now let's discuss the good coding practices for system Verilog assertion. Always use clocking in concurrent assertion. Never forget this. We have to use clocking in concurrent assertion. Okay. Use disable if for reset. Okay. This is the way. If we have to disable something when in case of reset condition, then we write like disable reset. Okay. And when reset is not there, we give the condition. Then give meaningful messages. Write modular properties. Use sequences for complex behavior. To write sequences in case of complex behavior. Assertions should be non-intrusive, which means they don't change constantly. Now let us conclude. So assertions are one of the most powerful features of system Verilog. Immediate assertions help you say simple and instant conditions. Concurrent assertions help you verify complex multiple behavior. If you master SPA, you will write stronger test benches, catch bugs earlier, and perform professional level verification. That's all for today.